Hello everyone, welcome to Voxcel. I hope you're doing well. In this video, we're gonna discuss reading passage 3 of second test of Burlington Academic Book 2. We have already discussed passage 1 and passage 2 of this book, so if you haven't watched those videos, you should watch them, but after this. So without further ado, let me start. So if you are familiar with our ritual, with our routine, you know what we do first is we read our title of the passage and some extra information if there is. Origami and engineering, adapted from a review of origami applications in mechanical engineering. Copyright. Okay, so this is the topic which we are gonna read now. So I hope you know about origami. If you don't, I'm just gonna give you some brief information about it. So it's basically a traditional Japanese art. So what we do in this is we take a single flat sheet of paper and we fold it into three-dimensional images, like in some sort of animals or images of some sort of flowers or some sort of geometric shapes. Okay, but we don't use any glue or we do not cut it. Just we fold the paper. We have such techniques that we fold the paper into different forms. And I think there is some, yeah, this is like an image of origami, you can see. So we fold papers like these, so to make images like that. This is like geometry shapes. We can fold it according to to make it look like animals or flowers also. I hope you got it. You got an idea. Okay. Now, second is engineering. So I hope you all know about this. This is a branch. Okay. So, and what branch of engineering we are dealing with? Here it is written in the extra information. We are dealing with mechanical engineering specifically, not electrical, not chemical, electronics. So here they are saying origami applications in mechanical engineering. So what more in it is when we will read the passage we will come to know about it, but right now we can get a very good image of this particular passage. So now what we're gonna do is we are not gonna read the paragraph just yet. We are gonna sorry about that. We're gonna look at the questions, see what kind of questions we are dealing with, and then make a strategy according to that. So we have to solve questions 27 to 40. So first set of questions is 27 to 30, and here we have to match the correct ending with the statement. So what is given to you is you are given these four questions, and then you are given seven different endings. So you will have to match the appropriate ending or the correct ending with each statement. So that option that you're gonna select should not only be correct, but it should also be grammatically correct. So let's just say if you think that this is, like for example for 27, if you think B is the answer, so B should also be grammatically correct according to this particular sentence. It should not mean something else, or grammar should be appropriate, it should not be inappropriate. Okay, moving on to 31 to 35. So we are given true, false, not given. So we have to tell whether the statement is true, false, or not given. And then blanks. So we have to write. This is very important to understand. You can only write one word only. So if you write more than one word, your answer will be marked as incorrect, though maybe one of your those two words is correct or is the answer, but if you exceed the word limit, your answer will be marked as incorrect. So you should be very careful about this also. So now what we're gonna do is we're gonna read these paragraphs and then we're gonna solve the questions. So what we can do is, like, for example, we will read, like, just say we will read this paragraph. Okay, so then we will try to see whether any of the ending is answer is in this paragraph or not. After that we will see if any true false is given here or not, or after that we will see if any blanks is here or not. So for that what we can do is, either you have two or three options for that. Obviously you can read all the sentence endings because these are This doesn't mean that 27 will be A, 28 will be B. So 27, it can be anyone from A to G. So you can read all the sentence endings, then read the paragraph. So if you find the information, you will have some sort of mental image in your head that what kind of endings you are dealing with. Okay. Or what you can do is just read the paragraph and then start reading the questions one by one. It's up to you, whatever you prefer, you can do that. But what I'm gonna do is I'm gonna read the endings first. Why? I'm just gonna give you simple reason. Because after reading the paragraph, if I read the like these endings, you will get to know if there is any answer, you will get to know the answer very easily, so you will not have to use your own vocab or something like that. But if I read this first and then this, then you will have to match it by yourself. I will help you to match it after giving you some time. So for solving every question, I will give you about 10 seconds. So after 10 seconds, I will tell you the answer, and I will tell you the location and why that is our answer, and I will explain to you thoroughly. Okay. So now what we're going to do is we're going to read the endings now. First option, as it allows greater extension in the third dimension. So whatever the answer is, this what this option is saying, it allows, whatever the option is, it allows. So it means whatever is given in the statement, greater extension in the third dimension. So we are given three dimensions, 1D, 2D and 3D. So in the third dimension we can get greater extensions. Use of plastic material, so we can use plastic materials for this. Origami is long and rich history, so this history is not only long but it is rich also. By developments in several fields of science, so we have been developing these, but we have, like, we are getting developments in not only one aspect of science but several fields of science. E, as it has a greater number of fold types. So you know, in origami we fold the paper, so it has greater number of fold types. So maybe the other types will have two or three folds, it may have four or five folds, something like that, so the number will be greater. F, as the adjustment for thickness of the material is required, as the adjust sorry about that, as adjustment for thickness of the material is required. So we can adjust according to the thickness of the material that we require. As they involve materials not found in nature, so it involves those materials that are not found in nature. So these materials are something unique, you can say. Okay, now we're gonna read 27th. Okay, we're gonna read the paragraph now, then we will see if our questions, any question is here or not. The word origami, the ancient art of paper folding, combines the Japanese roots ori means meaning folded and kami meaning paper. So again, if you don't know about the meaning of origami, they have told you in the first sentence itself. So this origami word is made up of two words. First is ori, it means folded, and kami, it means paper. So origami means folded paper. Despite origami long aesthetic history as an art form, so it has long aesthetic history as a art form, the vast majority of practical applications have emerged in the last 50 years. So we have been getting a vast majority of practical applications in the last 50 years, not before that, but in the last 50 years we are seeing a lot of developments, you can say something like that. Advances in computer science, number theory and computational geometry have paved the way for powerful new analysis and design techniques which now extend far beyond the art itself. So they are saying that we have made advances in computer science, number theory and computational geometry, and it has made the way for powerful analysis and design techniques, okay, now which extend far beyond. Beyond basically mean outside the realm or outside the zone of art itself. So meaning to say, it has no, it is not only art now, so it has exceeded the limitations of art. Now it is used in computer science, number theory and computational geometry as well. Mechanical engineering has always been concerned with devices that allow relative motion between components. So, what is mechanical engineering? It is written here. This relative motion has many similarities to folding. So, mechanical engineering, it is concerned with relative motion, and this relative motion has similarities to folding. However, the field of mechanical engineering origami is a recent development, and it is leading to new and useful results. But this particular field of mechanical engineering origami, it's quite a recent development, modern development, and it is leading to new and useful results. So we are getting results out of it, mind you, but they are new, but these results are useful. Okay, so what is given in the paragraph? In this paragraph we are we are told about origin of origami, what the word means, what was it in the past, what it is nowadays, and what are the recent developments. So these kind of things are given in this paragraph. So now we will read the 27th question, or these question, and see if any answer is here or not. 27th: wider use of engineering origami was made possible. So, do you think 27th is here or not? So 28th, the Yoshimura. So we haven't read anything about Yoshimura, so we don't need to read other further questions. But first, concentrate on 27th. So you have around 10 seconds to tell me whether 27th question is in this paragraph or not, and if it is, what is the answer? And your 10 seconds start now. Okay, time's up. So now tell me whether 27th answer is here or not. Yes, it is. The answer is in this particular paragraph. And what is the answer? First, let me mark the answer here. Then I will explain you why that is the answer. The answer is option number A, B, C, D, E, F, or G. Yes, option D. So let me mark the option first: by the developments in several fields of science. So now let me explain it to you why the answer is D here. The question is saying wider use of engineering origami was made possible. So wider use just means whatever the use was previously, now we have extended that particular field of use. So of engineering origami, so we are now using engineering origami. It was made possible. Why? Okay, here it is written. Mm, so it is long and art form. So the vast majority of people emerged in the last 50 years. So advances in science, computer science, number theory, and computational geometry have paved the way for powerful new analysis and design techniques, which now extend far beyond the art itself. So because of this, because of the developments, now this is not only used in art, it is used far beyond the procedure of arts or the purpose of art. It has exceeded its purpose of art. I hope it is clear. Okay, moving on. So 28, the Yoshimura pattern. We haven't read anything about Yoshimura, so there is no need to like read options for this. Theoretical models differ from practical models. Sorry, applications. We haven't read about difference here also. Folding along valley sides differ from. No, we haven't read anything about folding from valley sides or folding along mountain. So only 27th is here from these questions. Now moving on to true false not given. 31. Common engineering materials have similar properties to paper. Have we read anything about these kind of stuff? Common engineering materials, properties of paper? No, we haven't read anything about it. So obviously this is not our location. 36. The art of origami has long been admired for its dash qualities. So have we read anything about the art of origami? Yes, we have read it. Yes, we have. So it has long been admired for its dash qualities. So okay, the answer is in this particular paragraph. Obviously, now you will have around 10 seconds to tell me the answer, and your time starts now. Okay, time's up. So what I'm gonna do is I'm gonna write the answer here first. Sorry about that. And the answer is yes. What answer did you come up with? Yes, aesthetic. So let me mark here. So where it is written, the art of origami has long been admired in something like that for this dash qualities, aesthetic qualities. Yes, here let me change the color. Long dash history as an art form. So despite meaning to say, because it was used like this and now it is used like this, so these are the changes that have been made at present, but in the past it was viewed as an art form, so it has long aesthetic history because of its aesthetic qualities. So we cannot write there any more than one word, so we cannot say long aesthetic qualities. It would not make sense after all, so we will only write aesthetic word here. I hope it is clear. Moving on to the 37th, let's see if 37th is here or not. Folding results in relative dash between components. So we haven't given any information about this particular statement, so yeah, only two questions are there, 27 and 36. I hope it is clear. Moving on to the second paragraph. Okay, so we will read this paragraph now. First, it is important to understand some common terms associated with origami. A crease is a fold. So, what is a crease? So we call crease a fold. So, whenever we fold the paper, that particular thing is called a crease. Either convex mountain or concave valley. So either your paper is going upwards or downwards. So that is called, if it is going upwards like a mountain, so we will call it convex, and if it going downward dipping like a valley, we'll call it concave. Collectively, all the creases make up the crease pattern, so all the creases we call it a crease pattern. The water bomb base, the Miura Ori pattern, the Yoshimura pattern, and the diagonal pattern are all rigid foldable crease patterns. So these all they are called, okay, so these patterns, they are rigid foldable crease patterns. The first two can be expanded in all directions. So what are the first two? Water bomb and Mura Ori pattern. So they can be expanded in all directions. The Yoshimura pattern is capable of translational motion up and down and side to side, and the diagonal pattern allows for rotary motion. So the Yoshimura pattern is used for this, and diagonal pattern is famous for rotary motion. So left common origami crease patterns include, this is called water bomb, B is called Muri Ori pattern, this is Yoshimura, and this is diagonal pattern. Okay. So dashed lines show mountain folds, while solid lines show valley folds. So whatever these dotted lines, dashed lines, they are mountains, and dotted are valley folds. Write a model of an expanding Muri-Ori pattern. So this is the model of Muri-Ori pattern. That is B. Okay, so we don't have to concern too much about this. Let's read the questions now. The Yoshimura pattern differs from Muri Ori pattern. So, is there answer here? Of course, we have read these names here. Here it is written Yoshimura, here it is, and Muri Ori pattern. Okay, so now you will have around 10 seconds to tell me the answer to this particular question, and your time starts now. Okay, time's up. If you need more time than that, what you should do is you should pause the video, and when you are ready with your answer, you can continue. But right now, I'm gonna tell you the answer, and sorry about that. And the answer to this is option A, as it allows greater extension in the third dimension. So in the 3D third dimension, it allows a greater extension. So I hope everybody was able to arrive at the correct answer. So these are the two patterns. So we have to tell the difference between these two patterns. So here it is written Yoshimura pattern. So the first two basically means Muri Ori pattern. So what does Muri Ori pattern does? It expands in all directions. Okay, but Yoshimura is capable of translational motion, not only up and down but also side to side. So that's why it allows for like greater extension. We can not only use for up and down, but we can also use side to side. So here, if you look at this particular thing, right hand side here, where my cursor is moving, uh, let me do this. Yes, this particular thing you can see here. Let me see if my pen works here. So no, it is not working. Okay, yes. Now if you look here, so this particular thing, it is only two dimensional, so you can either expand it, but for this, for the second one, they are saying that the Yoshimura pattern, it is capable of up and down and side to side. So the DAX 3D motion is greater here. I hope it is clear. Now moving on to the true false. Common engineering materials have similar properties to paper. Is there any mention of common engineering or paper properties? No. So obviously your answer is not here. We will move forward to the next set of questions. 37. Folding results in relative dash between components in structure. Okay. Is there anything about folding in this particular paragraph? Yes. Let me change the color first. Yes, here it is written a crease is a fold. So obviously there is something about folding. So the question is saying folding results in relative something between components in a structure. So whatever is in a structure, the folding results in relative something. So you have to tell what is that particular thing that results due to folding. Okay, so this is your paragraph. So let's read it again, and then I will give you 10 seconds for this. A crease is a fold. Okay, so collectively all the creases make up the crease pattern. So folding folds make up folding pattern. The water bomb, the Muriori pattern, the Yoshimura pattern, diagonal pattern are all rigid foldable crease patterns. The first two can be expanded in all directions. The Yoshimura pattern is capable of translational motional, and the diagonal pattern allows for rotary motion. So yes, there is something about relative something. For that, I will not tell you the exact location. I will give you an approximate location, or you can say relative location of the answer, and the answer is in this particular sentence. I will not tell you the exact answer right now. So you will have around 10 seconds to tell me the answer, and your time starts now. Okay, time's up. I'm gonna write the answer here and see whether you were able to arrive at the correct answer or not. And the answer is motion. Where it is written? Here. Let me write the answer first, then I will explain to you. This is question 37. So where it is say all I have already told you crease means a fold. So now they are talking about all the different kind of patterns that we have made through creases, folds basically. So the first two, when you fold these, they are capable of translational motion. So translational motion basically means moving from one point to another. So relative motion, same one and the same thing, components in the structure. So these things can be moved from one place to another. So like from this point, so if you look at the diagram here, let me use my pen if I'm able to do this right now. Okay, so from this particular point to this particular point, that is your translational motion. So relative motion, folding results in relative motion here. I hope it is clear. Okay, let's read 38th question and see if that is here or not. Circular motion is allowed by the dash pattern. Okay, do you think our answer is here or not? So you will get 10 seconds for this. Let me simplify it for you. Yes, our answer is in this particular sentence. Again, this particular sentence, because that this sentence is one sentence. So our answer is in this sentence. What is the answer? You will have 10 seconds to tell me that, and your time starts now. Okay, time's up. What I'm gonna do is I'm gonna write the answer here. And the answer to this is diagonal pattern. So where it is written circular motion, if you were able to tell me the answer, congratulations, very good, proud of you. But can you tell me where it is written circular motion? Yes, here rotary motion. So rotary motion, rotating, so obviously in a circular motion. So the rest is here, and this is diagonal. So let me do this. Let me mark the option, then I will explain it to you a bit more. Okay, so here they are saying circular motion is allowed by dash pattern and the diagonal pattern. So this particular pattern, it allows for rotary motion, and rotary motion is basically circular motion. I hope it is clear. Okay, let's read 39th question. Production cost could be reduced by increasing the dash of fold. So there is no mention of production cost. So wherever it is written production cost, we will know our answer is in that particular sentence. So now what we're gonna do is, so there is no mention of any common engineering material. So we're gonna read the next paragraph. Okay. The material used to create origami is critical. So now they are talking about the material which is used to create origami. It is quite critical. Critical here means important. Okay. Artistic origami uses paper, which is an elastic material that prefers to be flat. But other materials are more useful for engineering. So here they are saying that artistic origami, it uses paper because it obviously it's flat, obviously. But other materials are more useful for engineering. Obviously, for engineering, instead of paper, there are other materials that are more useful. One challenge in moving from theoretical origami to engineering origami is that materials have finite thickness, unlike in mathematical models that assume zero thickness. So we have a challenge, a difficulty, okay, a problem where if we want to move from theoretical origami to engineering origami. What is the problem? That material have finite thickness. Obviously, every material on earth have some sort of will have some sort of thickness. No matter how slim it is, it will have some sort of thickness. But in mathematical models, what we assume is materials do not have any thickness. To address this, so address meaning to say solve, the volume of edges on valley sides can be trimmed to avoid self interaction intersection, sorry. So the volume on the volume of edges, so the edges, the corners of the like particular material, it can be trimmed to avoid self intersection if material is properly assembled and creased so that it can locally bend and deform to the desired shape. 3D structures can be made or self folded with these. So if we can do this particular thing, okay, so if this material can be properly assembled and creased, why let me remove this, so that it can bend and deform to the desired shape. So if we are able to do this, we can easily get 3D structures. With the whatever 3D structures we need, we can get that. I hope the paragraph is clear. Moving on to the questions. Number 29. Theoretical models differ from practical applications. Is there any mention of theoretical models and practical applications? Yes. So now you have around 10 seconds to tell me the answer to 29th question, and your time starts now. Okay, time's up, and let me first mark the important words. So, what is the answer to this question? And the answer is, drum roll please, G, as they involve materials not found in nature. So, where it is written, can you tell me? Yes, here. One challenge, and this is the problem of from moving practical to from theoretical to practical. We do not find these materials in nature because every material has some sort of thickness. No matter how slim it is, it may be point zero zero something, but it will have some sort of thickness to it. But in practical, sorry, in theoretical, we what we do is we assume materials have zero thickness. Now we will read the 30th question and see if it is here or not. Folding along valley sides differ from folding along mountain edges. So, is there any mention of valley sides and folding? Sorry about that. Or any mention of folding along mountain edges? Let me do this. Is there anything mentioned about valley sides? Yes, here it is. So again, this is your location. So you will have around 10 seconds to tell me the answer, and your time starts now. Okay, time's up. Now I'm gonna write the answer here and see whether you were able to find out the correct answer or not. And the answer to this is option F. Let me mark here. As the adjustment for thickness of the material is required. So where it is written? Yes, here. First, let me write the question number, then I will explain. So here they are asking about the difference. So what is the difference between these two things? So here we are saying for in the 29th question, what we said, the main issue is this is the material with zero thickness uh, does not present in nature, doesn't occur in nature naturally on its own. So what we do is to address this problem, to address this issue, we trim the edges to avoid self intersection. So that's the difference. I hope it is clear. So adjustment for the thickness of the material is required. So how we adjust the thickness? By trimming it. So this is the difference. I hope it is clear. Now, moving on to the next set of questions, true, false. Let's see whether there any question is here in this paragraph or not. Common engineering materials have similar properties to paper. Okay, let me change the color. So, is there any mention of common engineering materials and paper and about their similarities or differences? Yes, let's read the location then. Artistic origami uses paper. So here is mention of, sorry about that. Here is the mention of uses of paper, okay, which is an elastic material that prefers to be flat, but other materials are more useful for engineering. So here is the mention of materials for engineering, common engineering materials. So this is our location. So again, you will have around 10 seconds to tell me the answer to this particular question, and your time starts now. Okay, time's up. What I'm gonna do is I'm gonna write the answer here, and the answer to this is false. I hope everybody arrived at the correct answer. If not, don't worry. I'm gonna explain it to you why it is false. In the question, it is saying that common engineering materials, what they have similar properties to paper. Okay, when the answer will be true, where yes, when the properties are similar of both these materials. When it will be false, when the properties are different. Okay, not similar, but they are different. When it will be not when it could have been not given, when we don't know whether the properties are similar or different. But here they are saying paper, it's an elastic material that prefers to be flat. Okay, that is the property of paper, but other materials are more useful for engineering. So what does but means? But means in contrast, opposite. So here they are saying opposite to paper, so we are using materials whose properties are opposite to that of paper. So we don't need paper for this, we need other materials. I hope it is clear. So the connector here but is very important to understand. So it is used for contrast. Okay, so we have paper on the one side, but we don't need paper, we need other properties that are more important for us. We don't need this property. I hope it is clear. Let's read 32nd question. Maybe we will find that here also. The development of folded shopping bags was the result of consumer demand. Okay. So have you read anything about folded shopping bags development and it's the result of consumer demand? No, we haven't read about anything about it. Okay. Now coming to this, production cost could be reduced by increasing the number of folds. Is there anything about production cost or money or finance? No, there is no mention of this here also. So obviously we will not. Okay. So now what we have done is we have completed this set of questions. Now we have to focus on the remaining two sets. Okay. Now focusing on this particular paragraph. Engineering origami can be used in a number of ways by the packaging industry. So they are saying this origami, engineering origami, it can be used in a number of ways. So it can be used in different ways. So a number of ways just means a different ways by packaging industry. Most engineering applications of origami use materials that are more rigid than paper. So we use materials that are more tough than paper, so that do not crumble that easily basically, or that are stronger than paper. More rigid materials often form the packaging of consumer goods, and engineering origami can be used to develop automated folding processes and to ensure that the packaging is efficient. So what we do is we use more rigid materials for packaging of consumer goods. So whatever you are like ordering from online or from any particular shop, when they are delivering it to your home, they are using rigid materials for packaging those goods. And because of engineering origami, what we can do, we can develop automated folding process so that packaging can be as efficient as possible. One recent example, so now, okay, sorry about that. One recent example for this is origami in packaging is, so this is the example, origami in packaging, this is the recent example of this: flat folding rigid shopping bag. Okay, so now we are told about something about rigid, sorry, flat folding rigid shopping bag. The solution allows the bag to be remain base of the bag to remain rigid. So what's the solution? We will allow the base. So base, what is the base? On which the bag rests, the low bottom side of the bag, while the upper portion is more flexible and the upper part is more flexible. Okay, so here it is: the development of folded shopping bag was the result of consumer demand. So here it is for shopping bag, folding shopping bag. So now obviously the location is here. So you have around 10 seconds to tell me what is the answer to this, and your time starts now. Okay, time's up. I'm gonna write the answer here, and the answer to this is not given. I hope everybody arrived at this particular answer, not given. Why it is not given? Yes, we are given the like development of this recent example is basically development of flat folding shopping bag, folded shopping bags. But why it was developed? What was the need? Was it the result of consumer demand, or was it the result of something else? We don't know about the result. Okay, why it was developed, we don't know about the reason. Was the reason consumer demand? Was the reason industrial demand? Was the reason uh, maybe any other reason could can be there? Okay, so we don't know about the reason, that's why the answer to this will be not given. I hope it is clear. Now 33rd question: collapsible shipping containers. Okay, so we haven't read anything about shipping containers, so when we will read about shipping containers, then we will read this question carefully. Production cost, again we haven't read anything about finance or money or any reason about that. Could be reduced by using, so and we haven't read anything about reducing money or production cost or our cost in general. So that here, that's why we have said not given, because we do not know the reason of this particular development. Okay, let's read the next paragraph. A larger scale variation on the theme of packaging is the development of shipping containers. Okay, now here is the shipping containers. So now we will read the question a bit carefully so that we can come to know where our location is. Collapsible shipping containers have been successfully produced. So collapsible means that we can like fold. Basically shipping containers, they have been successfully produced, so we have produced them successfully. When the answer will be true, when yes we have produced them successfully. When the answer will be false, when we were not or we are not able to produce them successfully, we have failed attempts at producing them. Okay, when it will be not given, when we don't know whether we are able to produce it or they are in just the development stage or not. We don't know anything about the production status, whether they are produced or whether we are not able to produce them. If we are not given any such information, we will say not given. Okay, let's read this. The transportation of empty container is inevitable in the shipping industry, and several attempts have been made to manufacture foldable shipping containers to save space. So here is foldable shipping containers. Simplicity and durability in unfolding and folding of the containers is a must, and lightweight materials should be used to keep the weight down. So far, two major foldable containers have been introduced into the market, but neither were commercially successful as they were heavy and were significantly more expensive than standard containers. Okay, so we have found our location. So our location is in this particular sentence. Okay, so now you will have around 10 seconds to tell me the answer, and your time starts now. Okay, time's up. What I'm gonna do is first I'm gonna write the answer here and see whether you were able to find the correct answer or not. And the answer to this is true. Now, where it is here. Let me write the location first, then I will explain. So most of you would have, or not most, let me backtrack this, let me correct this. Many of you might have said false, and it's perfectly understandable because distractors are given like this in this particular question, that a lot of students will think, yeah, it is false. Why? Because here they are saying neither were commercially successful. So if none of them were commercially successful, so it cannot be success, so it should be false. But no, what the question is saying they were successfully produced. So were we able to make them successfully or not? That is the ask of the question. The question is not asking us whether they were successfully, whether they were a success in the commercial market. Okay, we don't have to concern ourselves with this. So let me tell you why it is true and why it is not false. Listen very carefully. So they are saying that two major foldable containers have been introduced in the market. So foldable, basically collapsible shipping containers. So these two containers were introduced into the market. So basically we were able to produce them successfully. We were able to like sell them successfully in the market. Though they are two, but containers just mean plural. It can be two or 200, doesn't matter. So more than one containers. So the question is justified. So but here they are saying they were not successful commercially. So meaning to say people were not queuing in line. So they were not queuing in line to purchase them. So there was no queue to purchase them. But it doesn't mean that we were not able to produce them. We were able to produce them. You though they were expensive than standard containers, they were heavy. So here it is written. They were heavy and significantly more expensive than standard container. That's why they were not successful commercially. Okay, but we don't have to concern ourselves whether they were not successful commercially or not. Basically whether there was a demand of these containers or not, we don't have to concern, because question is not asking that. What question is asking? Question is asking whether we were able to manufacture them or not. Yes, we were able to manufacture them. That's all the question is asking. That's why the answer will be true. Hope it is clear. Now, 34th question. Foldable lithium ion battery. So, we haven't read anything about lithium ion battery. So, whenever we will read about it, we will read the question then. Okay, production cost could be reduced by increasing the dash of folds. Here it is obviously, it is written that they were expensive, but there is no mention of reducing the cost. So, obviously, our answer will not be in this paragraph also. Now, we will read the next paragraph. Origami techniques using rigid materials have long been used by the space industry in the construction of solar panels and inflatable booms for deployable space structures. So now they're talking about construction of solar panels and deployable space structures. The Muriori pattern was first introduced for the deployment of solid solar panels in space and continues to be used. So this particular thing we still use to deploy solar panels in space. This pattern is ideal for folding solar panels because it meets the requirement of being both rigid and flat foldable. It has also been used to create lithium ion batteries. So here is about lithium ion batteries that bend, twist, and fold, commonly referred to as deformable energy storage device. So these particular structure, Muri-Ori pattern structure, also used to create lithium ion batteries that bend, twist, and fold. So and they are commonly known as deformable energy storage devices. Now let's read the question. Foldable mm, foldable lithium ion batteries have been used in space. So if these batteries were used or are used in space, the answer will be true. If these are not used in space, the answer will be false. And if we don't know whether they were used in space or not, or whether they are used in space or not, the answer will be not given. Yes. So you have around 10 seconds. So this is our location, obviously. So you have around 10 seconds. Tell me the answer, and the time starts now. Okay, time's up. I'm gonna write the answer here, and the answer is not given. I hope it is clear why it is not given. Because we don't know whether lithium ion batteries are used in space or not. They had just told us that this particular pattern, Muri-Ori pattern, which is used to make solid solar panels in space, is also used to create lithium ion batteries that foldable lithium ion batteries. But where are these batteries used? We are not given that particular info, and for this particular reason the answer to this question will be not given. I hope it is clear. Moving on to the next question, number 35. The Yoshimura pattern allows the construction of circular design. Have we read anything about Yoshimura pattern till now in this paragraph? No, we haven't read anything about Yoshimura pattern. So whenever we will read about it, we will read the question then. And again, production cost could be reduced. There is no mention of reducing production cost or saving money, something like that. Okay, we will read. So two paragraphs are left. There are a number of other applications for origami. Car airbag designs involve folding an airbag into a compact state that allows it to be unfoldable in milliseconds. In addition, classic origami geometries are being used to create antennas and other electronic devices designed to collapse to small sizes. Antennas that will fit into a pocket, for example, can be used for a long distance communication when paired with other devices. So they have told us about other applications of origami, like in car bags, or we use them to make antennas. Okay, several designs for collapsible cylinders based on Yoshimura pattern. So here is about Yoshimura pattern have already been developed. Okay, let's read the question now. The Yoshimura pattern allows the construction of circular design. So if with the help of Yoshimura pattern we can build circular designs, the answer to this question will be true. But if we do not construct circular design, we can only construct, like just a square, rectangular, or any other kind of design apart from circular. Except circular, we can design anything else, then the answer will be false. And when we don't know what kind of designs we can make with this particular pattern, the answer will be not given. Hope it is clear. So obviously this is the location for this particular question, and let you have around 10 seconds to tell me the answer to question number 35, and your time starts now. Okay, time's up, and the answer to this question is true. So why it is true? So here the question is saying it allows for the construction of circular designs. So where it is written circular designs? Yes, collapsible cylinders. So cylinders are basically circular in design. So that's why the answer will be true. I hope it is clear. Okay, let's only now blanks are left 39 and 40 because we have done all the true false and we have done all the sentence endings as well. Only two questions are left, question 39 and 40. And in this, we haven't read anything about saving money or reducing production cost. So, I hope, and so that means both answers will be in our last paragraph. So, we will read this now carefully. Origami is an art form that is currently finding many engineering applications. In order to successfully implement these new techniques, progress is required in four key areas. So, for this, let me change the color. So, for this, we need progress in four key areas. Firstly, we need a better understanding of folding algorithms in order to fold intricate 3D structures efficiently. So, we need the understanding of folding algorithms. So we can fold 3D structures, intricate 3D structures effectively. So we can do this particular thing effectively. Secondly, we need to find ways to increase the mechanical efficiency to fold. Sorry, we need to find ways to increase the mechanical efficiency of folding to cut costs. So second thing we need to progress is we need to find ways in which we can increase the mechanical efficiency, so in which we can increase the mechanical efficiency of folding to reduce what, to cut costs. Okay. Thirdly, there is a need for research into entirely new crease patterns that allow folding in innovative and more effective ways. Finally, the design approaches and methodologies in origami engineering need to be standardized. Okay, so I was just reading it a bit further. So we have found the location to our 39th question, and that location is here. Okay, so I will give you around 10 seconds. I don't think so you will need that. You will get around 10 seconds to tell me the answer for this, and your time starts now. Okay, time's up. Now I'm gonna write the answer here, and the answer to this is efficiency. Let me just mark the answer first. Okay, so how we know that this is our answer? If you were able to tell me the answer, why, where it is written, reduce the cost, production cost. Yes, cut cost, reduce the production cost. So production cost could be reduced. Let me do this by increasing the dash of folds. So increase the mechanical efficiency of folds to cut cost, reduce cost, production cost, cut cost. I hope it is clear. Now looking at the last question, new crease patterns may become even further something. Okay, so even further, so we have to do this particular thing, that it can become something even more. So let's read. Thirdly, there is a need for research into into new crease patterns. So here it is written, new crease patterns that allow folding in innovative and more effective ways. So finally, that is something different. So obviously, third, this is our location, and you will have as always around 10 seconds to tell me the answer, and your time starts now. Okay, time's up. Now I'm gonna write the answer here. The answer to this is effective. Where it is written? Here. So new creases may become even further, and for further they have written more, more effective, further effective, more effective. So this is the end of this particular reading test. Yeah, we have done all these blanks, these true false, and these sentence endings. So we have marked the locations as well. So this is how you can attempt your reading. So though it may look to you like we are taking so much time for solving these, I am again gonna repeat this. It is taking time for me to solve or for you to solve this reading in the beginning or right now. Is I am trying to explain to you like in detail, but when you are going to solve yourself for yourself, you will not need to explain it to yourself again and again. You will read this particular sentence, you will understand, and you will mark the answer. So if you practice like this, if you practice enough, you will not need more than like 15 to 18 or more, around 20 minutes to solve one particular section. So most of my students, they are able to solve the readings within 55 to 57 minutes. So if you are not able to solve the reading, if you are like first timer, do not look at the clock. First try to understand how to solve the questions. Maybe it can take you 1.5 hours to solve one reading, or 2 hours to solve one particular reading, or maybe more than 2 hours, 3 hours, 4 hours. Do not look at the clock. First try to solve the reading at your own pace, at your own comfortable speed. And when you are like quite familiar with the types of the questions, when you are when you are confident that you can now understand the questions, you can solve the questions accurately, your speed, first of all, your speed will automatically increase. You do not have to worry about that. And secondly, then you can start looking at the clock, how much time you are spending on one particular section. Then you can make different strategies. But in the beginning, do not focus on the time only, focus on accuracy. So on this note, this is the end of this particular video. I will see you in the next video. Till then, take care and goodbye.